today's event is on low-carbon cities and transport. This is one of the first of the lecture series, of the seminar series, hosted by the Energy Futures Lab, which is Imperial's Global Energy Institute. And we're delighted that so many of you can join us here in person and online. So my name is Dr. Mark Stetler. I'm a reader in Transport and Environment in the Department of Civil and Environmental Engineering. And I'm really delighted to introduce to you Professor Sarah Sharples. Sarah is the Chief Scientific Advisor at the Department for Transport, and she's Professor of Human Factors in the Faculty of Engineering at the University of Nottingham. So from 2018 to 2021, she was Nottingham's Pro-Vice-Chancellor for Equality, Diversity and Inclusion and People. And Sarah has led research in transport, manufacturing and healthcare, and currently leads the EPSRC Connected Everything Network Plus. She founded and is co-director of the EPSRC Horizon Centre for Doctoral Training, and she has led research programs examining implementation of new technologies in rail, highways and aviation. So in a moment, I'll hand over to Sarah to give her presentation. After Sarah's talk, we'll have a Q&A, so do get thinking about questions, and if you're online, please do submit questions via the live chat function. If you're online and you see a question that you like, give it a thumbs up, and we'll go with the most popular question in the Q&A. If you're in person in the room, just raise your hand and we will make sure a microphone gets to you. So finally, this event is being recorded and it will be made available on the Energy Futures Lab YouTube channel. So we would encourage you to share that with colleagues that can't make it today. It gives me great pleasure to hand over to Professor Sarah Sharples. Thank you.
Thank you. Thank you. And first of all, happy International Women's Day to you all. It's a real joy to be delivering this presentation. Even though I've been in the job for nearly 20 months now as Chief Scientific Advisor for the Department for Transport, we still haven't quite got back into the swing of some of the face-to-face presentations. So as a sort of lecturer for 25 years, it is the thing that we particularly enjoy. And so I'm really looking forward to talking to you about low-carbon cities and the role of transport. But one of the reasons that I'm so keen to do talks like this is I want to influence those of you in the audience who are either already or considering embarking on a career in solving some of the problems that we face in decarbonisation of transport, and really tell you about some of the challenges that are really, really tricky from a scientific and engineering point of view, and ask for your help. So I am going to come with some sort of suggestions of the way forward, but I'm also really looking forward to the Q&A afterwards, where I can maybe hear about some of your thoughts, challenges and concerns as well. Just before I sort of start, I'll explain a little bit about what the Chief Scientific Advisor role is, because another reason that I do talks like this is I want to make sure that we've got lots and lots of applicants for the next time the role of Chief Scientific Advisor comes up at the Department for Transport. Because actually the first thing that brought this role to my attention was when I went along to a similar talk by the person who held the job 3 people before me. So it's an independent advisory role to the Department for Transport. So my job is to provide independent challenge to the department, but also to get stuck in and help. I will really commend to you the excellent work of the Department for Transport. When you're an academic for all of your career, it can be a bit daunting going into a government department and discovering a different way of working. But actually what I've really seen is a collection of really dedicated, thoughtful, highly intelligent people who are working together to solve some really, really tricky problems. And actually, a group of people who are quite open to challenge and quite open to some of the discussions that we're having here today. So if there is anyone who thinks, oh, I fancy being a Chief Scientific Advisor for any department, especially the Department for Transport in the future, please do feel free to sort of follow up and ask me any questions. So, what is transport? Well, transport is everything. One of the things I sort of read before I started the role in the Department for Transport was something that was written on a website. And it said something I strongly disagree with. It said, transport is not the sexiest of sectors. Well, actually, transport's amazing. Without transport, we have nothing. Without transport, we can't get to education, we can't get to healthcare, we can't get to leisure activities. The creative industries are hugely dependent on transport. But it's not just a means to an end. I firmly believe in the joy of transport, the joy of travel, and actually seeing travel as part of our everyday lives. But transport is currently changing in a way unlike anything we have seen for the past 100 years. If we think of not only the decarbonisation of transport that I'll focus on more in this talk, and the transition from the traditional petrol filling station to the notion of the electric charge point that appears to be such an issue that if any of you listen to The Archers, is now featuring as a storyline in Radio 4's drama The Archers. So we've got the transition from the petrol station to the charging station. We've got challenges around how and when and why we travel, particularly when we think about carbon-intensive modes like aviation. We've got the opportunity to do things like we have today, where we're online streaming as well as meeting face-to-face. But then there's things like, I just met Washington. I had forgotten that I've never met Washington face-to-face before because we've been working together for 18 months or so because of the ability that online technology gives us. And we're seeing an enormous transition in challenging some of the ways we're conducting active travel, such as the e-scooter, and that picture appears later on. It makes me laugh because I look like a very anxious 12-year-old on an e-scooter. So we are seeing a transformation in the way that we travel. But it's really important that we don't consider travel and transport in isolation of the setting in which it's based. So the title of today's talk is around low carbon cities. Well, what are our cities of the future going to look like? I grew up in Surbiton. I don't know, there may be people here from Surbiton, or everyone seems to have lived in Surbiton for a period of their time at some point. The original name of Surbiton Station was Kingston upon Railway, because the nearest big town was Kingston upon Thames, the old capital of the ancient kingdom of Wessex. And Kingston thought that trains were a bit of a fad, and they didn't want a railway station messing up their beautiful centre of the town. And in particular, there was a landowner that was very reluctant to have this horrible railway going through their local area. And so Kingston upon Railway, which then became Surbiton, was born. Surbiton is a town that has been shaped by the presence of transport. Anyone who's an Agatha Christie fan will see Surbiton Station feature with its Art Deco architecture in lots of Agatha Christie recreations, and Surbiton Station platform appears in Harry Potter as well, for any of you who know the area very, very well. And then we have my sort of London local station, St Pancras, one of the, if not the most beautiful building in London. Beautiful, beautiful architecture that from an engineering point of view is an absolute nightmare. Yet it is part of our heritage, part of our lives. And so the pure engineering solution, and please don't quote this in any sort of tweet after, knock them down, build them all again. Modular railway clearly is the way forward if we want to have a purely decarbonised city. But please do not quote the Chief Scientific Advisor for the Department for Transport saying St Pancras should be knocked down, because that would be the worst thing ever. So recognising that this isn't just about engineering. This is about the experience of travel, the experience of transport, the way that your heart leaps with joy when you go into the concourse at St Pancras. But maybe our cities need to start looking different. Maybe our cities will look different. And maybe the reality of the electric vertical takeoff and landing vehicles that you see in the top right of this image, or an organisation that was speaking to me just this week, the notion of, instead of having fixed heavy rail infrastructure, but much more dynamic, sort of on the rail it's a duo rail, not a monorail, solution that we see here, with pods that might divert into different branches as we go through a city. Maybe this would look different. The interesting thing is I looked at this and I thought, yeah, I've seen something a bit like that in Kuala Lumpur. I can absolutely imagine this in Saudi Arabia or a new built city where we have a really, really modern approach to architecture. But it feels a little bit uncomfortable when we think about somewhere like London or my hometown of Nottingham. So what is the city of the future going to look like, and how do we decarbonise it? Well, let's think about the current decarbonisation landscape. And I will be aware there are some people in the room who have much more experience than me and deep knowledge than me in this. But it's really important, I think, to recognise the context in which this work is taking place. We have a crisis. We absolutely have a necessity, not only because we have a legal commitment, but also because we have a moral imperative to reduce the carbon emissions that we are emitting as a human race. And in the UK, the domestic transport emissions, as published in the Transport Decarbonisation Plan that came out in 2021, showed that transport is responsible for 28% of the carbon emissions in the UK. And the distribution of those emissions you can see on the slide in front of you. The majority comes from cars and vans, and that's reflected in the policies that you know are already in place to encourage and influence the move to electric vehicles, moving towards the mandate for zero tailpipe emissions by 2035. But first of all, we also have other modes, which whilst they might have smaller contribution to the overall set of carbon emissions, are in some cases very hard to decarbonise. If we take maritime, and I have to read the number, 6.1% of the domestic contribution comes from domestic shipping. And actually, when we move to Carbon Budget 6, we also start to include international, which becomes even more complex. Shipping is an area that we talk about as being hard to decarbonise. Vessels that are on the seas now will still be on the seas in 2050. So we have to work not only to change the way in which those vessels use the currently carbon-emitting fuel, but we also need to think about how we retrofit existing vessels in the context of maritime. But we also have our heavy goods contribution. Heavy goods vehicles are 19.5% of that overall contribution of carbon emissions. So there are programs going on right now that are looking at large-scale demonstrators to test and pull through future technologies, because we know that batteries have a huge potential in areas like the automotive sector. But actually, as we get to larger vehicles and the larger power requirements, then gradually we get to a tipping point where the weight of the battery becomes too significant, and therefore the power efficiency of the vehicle becomes much less effective. So we have to look for alternatives, and some of those alternatives include things like hydrogen fuel cells. But it's not just about the vehicles. In the bottom right of this slide, you can see what I think is a really nice representation, which is overall sort of talking about the overall UK carbon footprint. And we see that some of that is not about emissions, it's not about industry, it's not about vehicles, it's about infrastructure. And what we talk about as embedded capital carbon. And we know that an additional 13% of those emissions are actually influenced through the infrastructure that is required to deliver our transport systems, roads and railways. And so thinking about primarily the role of concrete, and I'm a professor in human factors. I didn't know anything about concrete until I started this job, but I've become slightly fascinated by concrete since I'm in the role, and I've seen some of the examples of the work that's taking place. How we decarbonise concrete, an amazing infrastructure tool that we have, is something that we need to be considering alongside the changes to the vehicles that we're using. And the final thing I'll just talk about is this graph. So I'm a science advisor, I love a number, I love a graph. And I particularly like a fuzzy line like this, because there's a reason why these fuzzy lines, the blue, which is showing the path to net zero if we keep the policies as we have now, and the green path, which is the policies that are within the transport decarbonisation plan. So this is what we talk about in government as being the sort of analytical model behind the policies that are in place. But those fuzzy lines represent uncertainty. Now, within politics, within government, uncertainty is a really uncomfortable concept. It's really annoying. It would be much easier if we had very definite pathways towards the solutions we are working towards, but we don't. And so what that tells me is we need science, we need innovation, we need breakthrough technologies to deal with and address that pathway towards net zero. So what about cities? Cities are a really interesting sort of concept to think about. And I think the most important thing to take from this slide is that cities absolutely have a role in the way in which we address our carbon emissions. They're responsible for 45% of the UK total carbon emissions, actually proportionally slightly less than the population of 54%. 44% of the transport emissions and 37% of the industry emissions. But actually for me, the most interesting thing is on the right-hand side, where you can probably see a list of a number of different cities. And the diversity in the carbon emissions per capita of different locations in the UK. What this tells me is that we can't have a one-size-fits-all for cities. One of the most helpful things that I think anyone who works in transport can do is travelling around the UK, thinking about and recognising the diversity of the different cities that we work within and we live within. Because the solutions that work for Northampton, Doncaster, Warrington, towards the bottom of the list, are going to be different from Ipswich, Brighton and Chatham. So recognising that we have diversity of experience and recognising on this International Women's Day in particular, the importance of diversity of voice in the discussions and the solutions coming through to deliver our transport of the future is also really, really important. So let's think about some of the things that end up being talked about when we talk about decarbonising cities. So first of all, we have the context of decarbonisation. And we have the discussion of how, for example, the role of cycling could play a part in a city. Now, I don't know if any of you have ever lived in any European cities that are very, very focused on cycling, but the experience of cycling in a city can be transformative, not just from an air quality point of view or a carbon emissions point of view, but from a quality of life point of view as well. So what this diagram has hit, you know, my eyesight, I've hit 50 and I have to peek at the eyesight to read all the diagrams here. So what this shows is the changes in car traffic that have happened in low traffic neighbourhoods, and I recognise they're a controversial notion, but and I'll sort of come back to that a little bit in the future. The changes in car traffic inside and outside low traffic neighbourhoods in different settings. And again, I think rather than worrying about the particular figures here, the really interesting thing we see is that the impact of these schemes is different depending on the different settings. The nuances around the implementation of these types of schemes are really important. So when we have notions like the 15-minute city, that again is very controversial at the moment for various reasons, actually thinking about the nuances of what that means for particular different settings is really important. And I've been sort of doing this presentation with various bits of data for a number of months now, and it occurred to me the other day, I live in a 15-minute city. Where I live, on the outskirts of Nottingham, I can get within 15 minutes to healthcare, to leisure activities, to the shops, and to my friends, and to a transport system as well. So I think sometimes we get terribly worked up by the sort of ideologies around decarbonisation of cities, actually thinking about practically our experiences of what these mean is important. Another challenge that is sometimes placed on decarbonisation is, hold on a minute, are we thinking about the embodied carbon within vehicles as well as the overall emissions of vehicles? And there's been some really nice analysis to try and make sure that we're not just looking at what comes out of the tailpipe, but the whole life emissions of vehicles. And I think this graphic is quite nice, showing actually quite reassuringly that the evidence that is available at the moment does show that even if we do take into account the whole life emissions of the manufacturer of the vehicle as well as the tailpipe emissions, even when that is taken into account, then from a whole life basis, a battery vehicle will be lower emissions overall than a petrol vehicle. So the final thing I want to talk about before I move on to some sort of specific, I suppose, topics that we need to address are, actually, it's not just about carbon. One of the things that we were talking about just before the talk starts is the emissions of NOx, nitrous oxide, and particularly nitrous dioxide, which is a very harmful particulate that there is very strong evidence has impact on human health. So thinking about not only the emissions in terms of carbon, but also the emissions in terms of air quality is a really important thing for us to consider. And if you just, I would recommend for any of you who haven't already read it, the Chief Medical Officer Chris Whitty's report on air quality that was published about 6 weeks ago, 8 weeks ago now, that has a really, really nice description not only of the impact of air quality on human health, but also what can be done in order to address air quality from a systems point of view. It's actually quite positive about the steps that are being taken from a transport point of view, but really gives impetus and momentum to continuing and extending those policies. And really, just to put this into contrast, we can see that there's been really positive progress in terms of NOx emissions in London, as you'll all recognise, from 2013 to 2019. What's interesting here is not only that we've still got the high presence of NOx in the centre of London, but also that blob on the left, which is, of course, Heathrow Airport. And so thinking not only about the obvious, perhaps, NOx emissions that we have from the congested streets that we might see in central London, but also, and what you'll see from Heathrow Airport is it's a combination of car vehicle traffic and actually ground aviation vehicles that contribute to that NOx emission. And so recognising that we can't just think about carbon anymore is also really important. So I've sort of set out the challenges there. So what are the solutions? Well, I almost show this slide at every single presentation I do, and I will carry on showing this slide at every single presentation I do. And I used to, before the days of PowerPoint, I used to have a version of this slide printed out and carried around in my bag, because it's the slide that I use to explain the notion of human factors. Now, those of you at Imperial College, I hope, know what human factors is, because there are some human factors specialists who are based at Imperial College. But just in case you don't, human factors I tend to explain like this. Humans are fallible and humans are brilliant. Our job is to minimise the impact of human fallibility and maximise the value of human brilliance. The most important thing I would want you to take home from the definition of human factors is that human brilliance bit. All too often we focus on seeing the human as the weak link in a system. Let's design the human out of the system. No, sometimes the human is the brilliant link in the system that makes everything work in a seamless way, and we don't realise how brilliant we all are. Now, the reason that we say this is that all systems involve interaction now between people, technologies, and if anyone can ever come up with a better word than artifacts, which I always feel is a bit scientific-y, but then the alternative was things, and I didn't want that either. But basically physical stuff. The digital and the physical and people interact together. Let's think about this talk I'm giving to you now. I'm a person, I am emoting, you are looking at me, we've got people-to-people interaction going on. We're enabled by technology, but we're also shaped by the physical environment that we're in. And this is how we behave all the time when we jump on a tram, when we're riding our bicycle, when we're choosing where to put our e-scooter. We're affected by the physical infrastructure around us. As people, we have tasks. Engineers, human factors people, we're very good at measuring tasks. It's pretty straightforward, been done for about 100 years, and genuinely not rocket science. What's really interesting, though, is goals. And of course, what's even more interesting is it might not just be people who have goals anymore. If we're thinking about the advent of artificial intelligence, we've got this purpose that may start coming through from a technology point of view. But people, technology, and artifacts working together towards a mission is absolutely at the core of human factors thinking. We look at the local environment we're designing, the wider environment, and if we get this right, we lead to better outcomes in terms of design, in terms of performance, and in terms of culture. This doesn't happen in isolation. We work within legal and regulatory frameworks. We're experiencing social influences, expectations, and norms. If I started singing and dancing now, that would be slightly surprising, because we have social expectations that I stand at the front, you sit, we talk. Financial constraints and priorities place a reality on what we do. And, of course, the advent of technology affects the capability that we have. So, this isn't just an engineering problem. It's a systems problem. And this is, for me, the way that I explain that notion of systems. Because transport systems are complex. And they're so complex that we have all sorts of tools to help us understand how they're working. This on the left is a picture of the West Midlands Control Centre. It's really interesting. I mean, many of you, if you live in London, you're based in London, we've got Transport for London, an integrated transport system that is unique. Yeah, I think it is unique in the UK. Some of the unitary authorities are starting to come through where you've got control, you've got shared ownership of data. That means you can have integrated visualization of the different elements of the system. In the West Midlands, it's really interesting because actually this is a display that takes a range of open and proprietary data from different transport operators. It's everything from Twitter feeds that are explaining people's experiences of using the bus or using the tram, to some of the data that you might have from OpenStreetMap or some of the open source traffic information systems. And it's used by the operators to respond to and provide communications with the operators of the transport systems within Birmingham and the West Midlands region. Some of you will use tools like CityMapper, or some of you might have, this is an example of an example interface that is used to display to me the location of a delivery that's coming to my home. So we're all too used to using maps on our phone that tell us either where deliveries are or how we navigate and get to different parts in our journey, and how we navigate a multimodal system. These are technical overlays that are helping us as people make simple the complexity of the physical transport systems that we're engaging with. And all too often, I think we sometimes forget about the power of the effective user interface in enabling the implementation of future transport systems. And then this is a picture from actually near where I live in Nottingham, because we have a light rail network, and it's now brilliant, but when it was being built, it was an absolute nightmare. I remember when I did my PhD in the late 90s, and I did my PhD looking at virtual reality technologies. And some of my colleagues at the time were looking at the use of virtual reality to visualize underground pipework, because we knew that in the UK, we had a real challenge with not knowing what's underground. And therefore, and actually near where I live in Nottingham, just yesterday, there was a dreadful burst water main because there were some building works and people, I don't know what they were doing, but it was bad. They didn't know there was something under the ground and they dug into it and caused lots and lots of damage. You know, we're in 2023. This sort of thing really shouldn't be happening, but it's the reality of delivering a transport system. And so thinking about how we can really, really modernise the way in which we share and use data to manage our transport systems is, in my view, absolutely critical to decarbonisation. And then there are things that are perhaps slightly more obvious as links to decarbonisation. So at the moment, you'll be aware that there's an awful lot of work, as I say, even in the Archers, thinking about charge point infrastructure and how we make sure that not only do we have the technical capabilities to deliver new electric vehicles from an automotive point of view and increase their range, but make sure that we have affordable, equitable access to charging technologies. And we know that we need different solutions, whether it's people who are lucky enough to have off-street parking, people who might be able to charge their vehicles at a workplace, or people who need to be using on-street parking. But we also need to change our mindset. So my 82-year-old dad has, I quite admire this really, has bought himself a Tesla, and he still manages to come. He lives in the south, and he manages to come up and visit me, and came up just a few weeks ago. And he lives, it would take me about 3.5 to 4 hours to get to where he lives. He was happy to take 5.5 to 6 hours. Him and his wife are retired, and they were happy to build into their journey the stops that were required, thought about, they're fortunate enough to be able to happily afford to sit and have lunch while the car is charging. It fits their lifestyle. I'll be honest, and I'm embarrassed that as Chief Scientific Advisor, I still have a diesel, and it's an old diesel car. And I would have to change my mindset to change the way in which I drove to see my dad if I was to transition to an electric vehicle. So recognizing that that's nothing to do with the technology, that's to do with how we live our lives and how we plan to spend our time is a really important thing for us to consider. And let's not forget about that human brilliance. Let's not underestimate the ability of people to change, because attitudes towards electric vehicles are changing. This is something that I'm very fond of, actually. There's something the department runs very often, a sort of technology attitudes tracker. And they ask questions consistently over a period of time. So what we've got here are data from December 2017 to December 2021. And the data shows the agreements with, or the mentions of, the different issues that are either advantages to electric vehicles or disadvantages. So we can see that actually the awareness of, and this was the response to the question, which of the following, if any, do you think are disadvantages of electric over petrol or diesel cars or vans? In 2017, only 30% of people thought there were not enough charging points, but 73% did at the end of 2021. In 2017, only 23% thought that there were challenges around cost to buy, but in 2021, it was 71%. This isn't that these things have got worse, it's that they're changing in the public consciousness. Because we're also saying that people are increasingly recognizing the benefits, such as a vehicle being less noisy, a vehicle delivering more environmental benefits, or the advantage that we have at the moment around reduced road tax and did in 2021. So understanding public attitudes is really important to have alongside those technological developments. But very often, we don't see a single mode used for a journey. So if we're decarbonising our cities, we need to think about those whole journeys. We also need to recognise that much of the travel within cities is not people travelling, it is goods travelling, it's things travelling. And so thinking about last mile logistics is something that has had quite a lot of prominence over the last decade. What you've got on the bottom here is something called a pavement bot, the notion of a vehicle that would trundle up to your doorway and deliver your goods that you have ordered from the local shop or the supermarket or the depot, and thus eliminating the need for a person in that last mile section. The really interesting thing is that still needs to be a person or something or other to get the item out of wherever it ends up being delivered. You can imagine a quite simple robotic solution that, a bit like a wheelie bin on the back of a truck, that sort of moves the contents of the pavement bot into, let's say, a dedicated repository that you would then go and unlock. But you still need to go and get it from somewhere. So where we have people within the system is a really interesting notion. And then how we have people interacting with these technologies in spaces that are shared is also really interesting. We're already seeing this as a challenge with, for example, shared cycle paths or shared e-scooter cycleways, where we need to have the sort of negotiation we have between people and decarbonised solutions in those shared spaces. I mentioned before that some of the work that we're looking at is not just about decarbonisation of vehicles, but also decarbonisation of infrastructure. So not only do we have the embodied carbon with infrastructure we need to reduce, we also need to think about the vehicles that are involved in construction of our future transport systems. So one notion that's being explored here, particularly by National Highways, is connected and autonomous plant. So instead of perhaps some of the work you might have seen around autonomous passenger vehicles, thinking about what we could do to decarbonise and use technologies in quite difficult, hazardous work environments, such as building new roadways. What's really interesting about connected and autonomous plant is that there's real opportunity to deliver much higher effectiveness of operations through the autonomy and the connection between different elements of the system. But again, we've got this challenge that we're replacing people with technology. One example that came from some of the live trials that are happening of connected autonomous plant is this image on the top right here. Now, you're all people. You would look at that and go, I can see there's a continuous curved line in that image on the top right. What you won't see is what the computer saw, which is a real problem in that bit that looks like a walking stick at the bottom. The computer vision system that was part of this particular connected and autonomous plant system got itself into a bit of a pickle because it didn't read that as being a continuous line. So as we start to introduce more technology into our systems, we need to think about designing for technology as well as designing for people. So you'll see that there isn't a clear separation between decarbonisation and technology. This is all part of the same solution. I mentioned maritime before, and I realise we're talking about cities, but I think it's a really good example. Much of the saving that we can be delivering from maritime technologies is through what we talk about as smart shipping, through improving the way in which and the efficiency with which maritime vehicles will dock into ports. If we're thinking about decarbonisation of aviation, then actually one of the biggest challenges we have, which is the production of contrails, those particular types of patterns, some of which are very problematic in terms of carbon emissions and warming that we see coming from aeroplanes. Well, many of the solutions that we can have to address the emissions from contrails are about dynamically designing effective flight paths that mean that the speed and the height and the specific path that an aircraft takes can affect the extent to which they are emitting carbon during their journey. And we can be thinking about how we could be introducing autonomy into systems in order to deliver decarbonised transport solutions. Now, one decarbonisation technology that I haven't talked about quite so much, but actually this is an area where it's a plea for help, is hydrogen. Hydrogen is a much discussed solution within the decarbonisation debate. And one of the things I'm really keen on is we recognise it's a debate. We recognise that there is uncertainty in the delivery of hydrogen in the short and the long-term future. We know that hydrogen has the opportunity, particularly through fuel cells, to be zero emission at the tailpipe, with the biggest or the primary emission being, in the case of hydrogen combustion, water. We also know that there is significant work that's needed in order to deliver the efficiency from hydrogen, from the sort of what we talk about as sort of well to wheel, so the conversion of the raw material into the power that we need to fuel our transport mode of interest, that at the moment that is a much less efficient process than we see either from battery electric or from hydrocarbons. We also know that there are potential issues around public understanding of hydrogen. And this is an interesting piece of work that was done by some research teams, the UK ERC, and in terms of their top-of-the-mind associations for hydrogen, they knew about it as being energy, they knew about it as being renewable, they knew about its alternative role compared to fossil fuel in its emission of water. But they also said words like dangerous, expensive, safety, flammable, and risks. Now, the really interesting thing is, what if we'd ask the, I don't know, is it going to be the Victorians, about attitudes towards hydrocarbons or the people in the Industrial Revolution? So how much of this is our natural pathway to change, and how much of it is real issues that we need to be addressing? And there are, of course, real significant issues whenever we're looking at changes of fuels within a transport system. So thinking about public engagement and acceptance is really, really important. I live just outside an e-scooter trialling area, and I dread the moment when the local WhatsApp group or Facebook group has a conversation about e-scooters. Personal view, they're here to stay. So we just need to think about how we design effectively to enable, require and encourage safe use and safe co-use with other modes. You will have read in the newspapers the massive response that low traffic neighbourhoods have had recently. And you will also see from this diagram on the right that there is a dichotomy. There are 60, I'm just looking there because my maths tells me that 32 plus 28 equals 60, not 61. But let's assume there's a rounding error going on there. That we have 60% of people either strongly support or tend to support low traffic neighbourhoods, but we have 29 who tend to oppose or strongly oppose. So how do we resolve this dichotomy? Again, my answer would be cooperative design, bringing people with you as you design, but also thoughtful design, recognising that this is not a one-size-fits-all solution, and actually anything we can do to reduce the level of traffic within neighbourhoods is going to be effective. But perhaps some terms that become sort of politically couched can end up having a visceral reaction that's nothing to do with the reality of living in that environment. So I just want to sort of finish by thinking about the context of all of this work. So I've called this slide an innovation culture. I've got an amazing job, by the way, and I'm happy to answer any questions about it in the Q&A in a minute. One of the things I did was I went to visit some of the HS2 sites. And HS2 are doing some incredible things in thinking about how to innovate during a infrastructure delivery process. This is an example, and I told you I've become fascinated by concrete. So if there is anyone who's a concrete piling expert in the room, I apologise for what I'm about to do, which is explain something about concrete piling. When you have to deliver, so concrete piles are the big bits of concrete that go into the ground that are extremely important for the integrity of major infrastructure that we have. And when you fill a concrete pile, the poor quality concrete rises to the top, and you have to find a way to get rid of that poor quality concrete at the top. So what you do is if you're intending your pile to stop at the ground level, you'd pour an extra metre. And then, and I love this happened when I went to the Jaguar Land Rover factory, there was the same thing. In every engineering operation I've ever seen, there is a bit where you have to bash something with a hammer. And the way in which you get rid of the top of a pile is basically you bash it with a hammer. Well, the group of innovators who were working within HS2 said, well, this is a bit silly. And so they looked into how you could, within the appropriate regulation and standards, remove the concrete and use the vacuum technique. And again, it seems bleeding obvious when you talk about it. The first thing is that this directly reduces carbon emissions and carbon requirements. Secondly, it speeds up the process. This was HS2. In order to drill these particular piles, the West Coast main line had to be closed for some of the work. And so speeding up the process meant the West Coast main line was closed for fewer days as a result of this technique being implemented. So thinking about how we encourage an appropriate innovation culture, I think, is a key to decarbonising our cities. I'm also a firm believer in science not being considered in isolation of the wider economic value. My favourite example here is our Centre for Connected and Autonomous Vehicles within the Department for Transport, jointly with BEIS, as was. Around £300 million of government investment has directly leveraged matched funding from industry of £400 million. So that shows this is valuable, this is meaning that money is staying within the UK, which is really important for all of us who want to encourage the economic prosperity that we work within. But what's more important is that the companies that have been involved in those programs have since, and this number is much bigger now, attracted 790 million to 35 companies from venture capital. So thinking about the value of investment in research and development, the leverage that can deliver, and the prosperity that can result in is really, really important. And it's important for us all. Even if we're the purest of pure scientists, recognising the context in which we're working in is absolutely key. As is collaboration. So one of the groups that we have at the Department for Transport is called the Transport Research and Innovation Board. We get many of the different organisations whose logos you'll see on the screen, and I know they're the old government departments. I decided not to change it because we haven't officially changed the membership of TRIB yet, but we will be. We've got all of those to work together in order to fund collaborative research, to address some of the problems that you see and that I've talked about today. So I really just want to leave you with a hope that we can recognise but have the confidence to address the complexity of the challenge of low-carbon cities through creating communities of expertise, through thinking about the specific targeted questions we need to answer, like the breakthrough technologies we need in hydrogen production, like the step change we need in battery electric use of rare earth materials, and like lots of other challenges that we're talking about. We need theories, we need science, we need engineering to help us through this pathway, but we can't do it on our own. Working with industry, working with policy, working with innovators is the way to address this. And that will encourage innovation, that will deliver the breakthroughs that we need, and that will hopefully help us on our pathway towards low-carbon cities. So thank you all very much.
So now we've got a few minutes for Q&A. I can see a few hands that have gone up. So first one I saw was over here.
Thank you very much. Very insightful, interesting talk. I had a question on hydrogen for transport. I discussed recently with a friend working in German research and development of the hydrogen grid, and there I heard that they question hydrogen being compatible to long-term transport in ships and flights just because the energy density is not high enough. Is that also your vision, or what would be the alternative? Ammonia?
So the question around energy density of hydrogen is one that, as I say, it's my plea for help in a way. I think at the moment we don't know enough to not invest in hydrogen research, would be my first point. So I think it's really important at the moment that we have the right research and development happening to help us answer those questions. Personally, I think maritime as a pathway is something that we're seeing really strong potential for because the weight of a vessel means that battery is going to be extremely difficult. The other thing, and I'm going to forget this particular statistic, but basically the amount of power it takes, electricity, to plug in even like a major cruise ship on sort of shoreside power is extraordinary. It's something like the whole of Bristol or something like that. I can't remember what the Stansted Airport, that's right. So the whole of Stansted Airport is the same as one sort of onshore power for a cruise ship. So just the volume of battery electric as well as the weight of the battery from a maritime point of view becomes infeasible. Of course, there is another alternative that I didn't talk about here because we were talking about cities, but if we think about aviation, then sustainable liquid fuels, sustainable aviation fuels are another pathway that could potentially be a drop-in solution for maritime. But we know, and there was an excellent Royal Society report published, I think it might have just been last week, that articulates this much better than I can, that highlights the significant challenges that we will face around feedstock availability for aviation and then for sustainable liquid fuels more generally. So I think that, yes, there will be situations where the energy density of hydrogen is not ideal, but we need to take a systems perspective. I've seen some great stats, and actually I was talking to my colleague Paul Monks, who's my equivalent in now DESNZ, the Department for Energy Security and Net Zero, and we were thinking about some work that we really need to pull through, because there are some really significant challenges about thinking about the whole system. There is a world in which Paul in DESNZ could go off and come up with one answer, and I could come up with another answer in transport, and that would be extremely unhelpful. And so thinking about the whole system is really important, and therefore thinking about maybe some parts of the system where the energy density isn't ideal, but in order to deliver whole system decarbonisation, the appropriate solution is hydrogen. It is worth saying, and I'd be delighted if there was someone in the room who is of any of these sort of diverse views. There is so much diversity in the view around the efficiency and the value of hydrogen generally, and the pathway towards different energy densities, that I remain somewhat perplexed. And actually I've come to the conclusion we just need to have this debate in an open and informed manner. There are some really good initiatives that are happening. So there's the Hydrogen Innovation Initiative. There are the two hydrogen networks that are run by, I think it's Tim May at Bath and Sarah Walker at Newcastle, that I'm really hoping start to bring through these discussions, and it may be that some people in the room are part of those discussions. So I think that was a very long way of saying I see a role potentially for hydrogen in decarbonisation of transport, but more importantly, I see significant challenges in absolutely banking on battery, absolutely banking on sustainable liquid fuels, and therefore keeping hydrogen as part of the mix, I think, is really important.
So if I could just follow up on that, we've got these engineering arguments around energy density, both in terms of gravimetrics, so the mass and the volume that a fuel would take up, and also the efficiency of the supply chain of how you produce hydrogen, for instance, the renewable energy that you would be required to produce that amount of hydrogen. We've got these engineering arguments. We've also got sort of your background from human factors. How do they mesh? It might not be the most efficient technology that wins out.
Absolutely. And of course, so I'm going to use an analogy from a completely different part of the world. So I've got two examples, right? I'll go for the Apple computers example. So Apple computers, for those of you that are as old as me, remember, were incredible. And I'm just trying to think. So it's when I was at school. So let's say it was sort of mid-80s, something like this. Apple computers were far and away a better product than the Amstrad PCs at the time. But the Amstrad PCs won out. And for, 10, 20 years, PCs were everywhere in the market, and Apple were nowhere except for in some very specialist parts, usually university departments, that had spotted the high quality of the Apple computer. And then the market changed, and everyone knows the sort of history now. That was a situation where the best technical solution didn't win. Amstrad computers were not, and I don't think anyone from Amstrad would deny this, were not the best technical solution, but they were the cleverest marketed solution. So they were the solution that was affordable. They also had planned obsolescence. So after 2 years, 1 year, they would break, but they were cheap enough that you could cope with that, and you would buy a new one. So in terms of the, sorry, and I was answering, it was your question, wasn't it? I was pointing to you. So I think it's that systems perspective that's really, really important. But increasingly, and as I say, I'm a professor of human factors, so some of this is not my deep expertise, and it's why I'm so grateful for all the scientific experts that help us navigate through this challenge. The best technology is not going to win in every situation because the laws of physics are going to get in the way, and the fundamental availability of raw technology is going to get in the way, because of course it's even more complicated than that, because you need electricity to produce green hydrogen, you need hydrogen to produce sustainable liquid fuels, you have all sorts of things going around in circles in the system, and it's really complex to visualize. So I think it's perhaps less a human factors issue, it's a systems thinking challenge that we have.
Okay. Washington.
Thanks very much. Very refreshing. So, based on your presentation, I'm assuming that this silo mentality that maybe drives a lot of what we do here is not desirable, in the sense that everything is connected to everything else. So transport itself is already hyper complex. It then sits within a very complex system, which is a city. That's even, so the complexity level is pretty high. Do we have that expertise within the DFT? And how can Imperial College London help?
So I think the sort of the notion of the sort of expertise within the DFT is perhaps slightly the wrong way of thinking about it. I think we have awareness of this being a complex systems challenge, and as I mentioned in my sort of early remarks, that willingness to be challenged, I think, is also there, which I think is the most important thing. So I think that, but I'd like to sort of take that part of your question, how can Imperial College help? We need to get the balance between recognizing the complexity and articulating in accessible terms. Now, many of you will be people who either teach or have aspirations to teach or have been taught in settings like Imperial College. And someone gave me some very good advice. In fact, it was one of the first, if not the first, Chief Scientific Advisor for Transport, someone called Frank Kelly, who's now at Cambridge. And I think he's at Cambridge. I'm worried I've got that wrong now, but I think he's at Cambridge. He said, being a Chief Scientific Advisor is like giving lots of first-year university lectures. So actually, in answer to the question, how can Imperial College help? How can we make these complex issues simple enough that we can communicate them in first-year university lecture term, but without dismissing the complexity? I think one of the things that, and it was a colleague, I was in a meeting with a colleague, and they made a slightly disparaging, but with a twinkle in their eye, comment about diagrams with boxes and arrows. I can't remember if I showed you any diagrams with boxes and arrows, but do you know what? Sometimes I love a diagram with boxes and arrows because that's the way to represent the complexity of a system and the interacting factors within a system. But so Patrick Vallance said something really, really interesting, actually, which is, he said, from a science point of view, when we find new evidence, that's really interesting, that's really exciting, that gives us sort of joy and enthusiasm. He said, for a politician, new evidence can mean a U-turn. And so, and remember, of course, that the civil servants are, and I don't know if any of you are sort of civil servants, but the name is meaningful. Civil servants, your job is to serve. Your job is to sort of execute the requirements of both the UK and the ministers. And so, actually, it can be extremely frustrating when scientists and engineers go and speak to government and say, oh, it's really complicated, this is going to take us 20 years, give us 50 million. And so actually showing a pathway towards helpful advice during that process. And let's be honest, some of the challenges that I've presented here, 50 million won't touch the sides. It's, this is an enormous challenge. The US is spending $1 trillion on their infrastructure bill. Because they recognise the challenge and the importance of decarbonisation. And so I think, how can Imperial College help? Make research accessible. Think about how to brief from a policy point of view. I think that if that is done, then actually both within the Department for Transport, but also within the other relevant government departments, that will mean that the science and engineering can make a difference. And I realised, in a way, maybe that was a bit of a politician's answer, and I'm sorry about that. But I think it's that, how do we grapple with complexity and not jump to simplicity? So being comfortable with complexity is probably one of the most difficult things we need to do.
Can I just follow quickly, please,
Yeah.
just quickly? This has fascinated me for years, because you're a human factors specialist, right? Today, what is the proportion of the carbon problem can you assign to human choice or human behavior? In percentage terms, for example.
So I can't, I'd never make a politician, because I'm going to admit that I can't answer the question. So I don't know, but I do know that human choice can make a difference. And as I say, but I think sometimes that issue of human choice is boiled down to a too simplistic view of choosing whether or not to travel, for example. And I'd go back to the example about the charge point technology. I mean, it's dreadful, isn't it? I can't bear the thought of a journey that currently takes 4 hours taking 5 hours. I need to change. Otherwise there isn't going to be a world for my children and my grandchildren to sort of live in the future. So I think it's acceptance of, and I'm going to make a sort of, it's a phrase that I always get slightly wrong, but it's very relevant to my equality, diversity and inclusion role. When you've been used to privilege, equality feels like discrimination. Well, actually, I think there's a huge analogy that we can take from, and I've discovered that my work in equality, diversity and inclusion has given me an enormously powerful training for my job in the Department for Transport, bizarrely, because you're dealing with complex issues, you're dealing with systems issues, you're dealing with visceral responses from people, and you're having to implement that in the way in which we're leading and implementing policy. It's the same feeling, I feel upset that the journey that's currently 4 hours is going to take me 5 hours. Well, I need to take that on the chin because it's my responsibility to do my bit for the planet to change, and that's really inconvenient to me because I've been used to the privilege of using hydrocarbon fuels which have been emitting carbon. Oh, it's annoying, isn't it? I'm going to have to buy an electric vehicle.
Okay, we've got time for one more. There's a hand up over there that I've seen, but I haven't gone to yet.
It's worth saying I can stay around a bit afterwards if people want to ask me questions.
Yeah, there will be drinks
well,
afterwards.
Presentation is very clear. I think I have two questions. One is about, you haven't mentioned carbon capture in your slide, but it's actually very popular nowadays. And the second one is, what do you think about the intervention of the government? Because normally from our business study that if there's no intervention, then it's very efficient. But if there are so many tax and subsidies, then it's not like the free market, then we may risk. So which level of intervention you think will be the best?
Really interesting. So, so first point was about carbon capture. You're absolutely right. Carbon capture and, of course, storage are really important areas that we know there's lots of research going on. We know it's absolutely critical to, for example, sustainable aviation fuel and other sort of technologies. It's worth saying that other aspects of storage, like hydrogen storage, well, again, it's so annoying. Hydrocarbons are amazing because they're not just energy, they're also storage. And so we've got all of this sort of challenge that we've got to sort of deal with. So you're absolutely right, and it is part of the wider thinking. I'm going to apologise here because it's not primarily the role of the Department for Transport to worry about carbon capture and storage, but of course that means we must be cognizant of the context we're working within for the other government departments. You then asked a really interesting question about sort of the role of government and the sort of balance, I suppose, between a full sort of free market economy and then very strong government intervention. And I won't end up in a sort of getting myself in a pickle from a politics point of view, but I will observe that we need both elements to be considered. So. And I think this probably applies whoever is in, wherever you're sort of living. Different countries will take different approaches. People often use Singapore as a very strong example for some of the work around implementation of autonomy and different and different concepts. Singapore is a completely different culture from a government point of view to the UK. If we think about some European approaches, what's really interesting in Europe is the devolved power to cities, and actually quite strong government intervention at a city level, but that autonomy that comes with it being city rather than national. One thing I will say, though, is that we know from a UK research and development point of view, around a quarter of our R&D comes from government funding. We need the remaining 3/4 to come from industry. So it would be naive to not think about how we make sure that we have the industry responsibility and role and opportunity that comes through in R&D. And of course, the reason that industry wish to invest in R&D is that that is how they then develop ideas, they develop intellectual property, and they make money, because that's their job. So I think, and I will, and I know Mary's here, you know, that I do think that Imperial has been in a particularly leading role in terms of thinking about how it can work effectively with industry without in any way compromising the excellence of the science. And I think has been very interesting in terms of, for example, attitudes towards intellectual property, understanding what it means to have an ethical partnership with industry, because of course sometimes industry don't like the answers that R&D come out with, and so thinking about how to sort of work with that within an ethical R&D framework is really important as well. So, I maybe I could make a politician, because that was a politician's answer, but I think my answer is we need to consider both. Do you know, the funny thing is, I actually don't really have a view. I used to be more interested in politics before I started this job than I have become since I've taken on the job, because my job is to advise. My job is to make sure that the science evidence is articulated clearly, is understood, is fed in, but it is the minister's job to decide. And the ministers have complete freedom and opportunity to say, actually, there are a number of things that I'm considering, and science is one of them, but I'm going to let this particular consideration have greater weight. And that's that's what happens when you live in a democracy, and that's how it works. So I've actually surprised myself by how relaxed I am about that sort of context of work. When I was applying for the job, every single stage of the interview, they said, what will you do if a minister ignores your advice? And I gave the same answer every time, which is that I would give the advice clearly. If it was safety critical, I would give it really, really clearly, and I would write it down, and I would copy it to a lot of people. But it is the minister's job to decide, and it's my job to advise. And so we leave that particular sort of the ideological perspectives come from the ministers.
Thank you for all the questions. I'm going to take this opportunity. I can't let you leave without just answering one more question. What is going on in Swansea and Middlesbrough?
So
in your your figure you had, and this is putting you on the spot.
Industry.
Okay.
So, gosh, I'm glad I did pay attention to that graph. And so industry. So proximity of industry.
So this isn't just a transport footprint.
No,
it's everything.
It was overall footprint. So,
okay.
But yeah, so good. And I think that I think that came from one of the Centre for Cities reports. I think, was it?
Yeah.
I mean, that's the other thing that I wish. I slightly wish earlier in my career I'd paid more attention to the excellent sort of think tank type reports that are out there. And I think any of you who I can see in the room, I'm making gross assumptions. There's a range of different career stages here. Those of you who are early in your career, do try and spend a little bit of time looking at some of the excellent reports that are written by expert think tanks. So Centre for Cities is a good example. Green Alliance is a good example. Yes, sometimes they'll have a political view that they're putting across, and always try and understand what that political view is. But actually, good evidence bases don't just come from academic papers. And don't get me wrong, the academic and the peer review papers are absolutely essential to our scientific way of working. But I think I probably could have done a bit more reading around and understanding the context of my work earlier in my career. And reports like those sort of Centre for City reports are excellent.
Thank you. Thanks. Let's please thank Sarah once more. Okay, so thank you all for joining. Thank you to Sarah again for being our speaker this evening and giving up your time to join us. Please feel free to join us for a drinks reception outside and look out for the next Energy Futures Lab event. Thank you.